6.4, Writing Linear Equations in Standard Form. All right, so once again, please excuse me if something erases. I will make sure that I rewrite it. The first thing we have here is what standard form is. We have used standard form before when we were graphing equations. Standard form is ax plus by equals c. Now, the checks that we have for this to make sure our standard form is in the correct format is that we need to make sure there are no fractions in our equation. So a, b, and c, which are represented by numbers, cannot be fractions in its final form. Now, the second thing is I need to make sure that ax plus by is in this order. The third thing we need to always make sure is that our a term is positive. If for any reason, now a term, this one right here, for any reason that something is not in that order, we will rearrange it. If there are any fractions, we will make sure we cancel them out. And if a is not positive, we will change the format of it to make sure a is positive. Okay, so let's move on to some practice problems. The first two we have here are both written in slope-intercept form, y equals mx plus b. So what I'm going to do first, I'm going to start with this problem, number 1. I'm going to get rid of that fraction because right now I know I cannot have this fraction of 1/2 in my equation. But in order to keep the integrity of this problem, I can't lie, steal, or cheat. I need to make sure when I get rid of that fraction that I keep the problem's integrity in whole. So if I'm getting rid of that fraction, I can multiply this equation by 2, which is the LCD. And I'm going to make sure I multiply every term by 2. Now, I know some of you, when you try to get rid of fractions, you forget to multiply everything by that number. So I would put those arrows in order to make sure you are multiplying everything by that value. So the first one I get from multiplication is 2y. Equals 2 times 1/2 will just leave 1x. And the last one, negative 1 times 2 is negative 2. Okay. Next thing I need to make sure is I need to get this problem in order. Right now you can notice that y value is already on the left side of the equation, but the x value is not. The constant is on the right side of the equation where it needs to be. So the only thing I have to move over is the x value. So in order to move that x value over, I'm going to subtract x from both sides. So I'm going to make sure I write it in order, ax plus by equals c, meaning my x term needs to come first. So I have negative x, and that is a positive 2y, equals negative 2. Now that I've gotten rid of the fractions, put it in the right order, my last step is to make sure a is positive. Since right now a is not positive, I need to change it without changing the actual problem. So there's two ways of looking at this. You can either multiply by negative 1 or divide by negative 1. That is the same step. So I'm going to go ahead and I'm going to do multiplication of negative 1. Now I need to make sure I multiply every term by that. So I'm going to put my arrows. So my first one will be negative 1 times negative x is x. Negative 1 by positive 2y is negative 2y. And negative 2 times negative 1 gives me a positive 2. Oops, let me move that back down. All right, so now I can double check to make sure my equation is in standard form. I have no fractions from a, b, or c. I have it in order. The x term comes first, the y term comes second, and the constant is by itself on the right side of the equation. And my a term is now positive. So this is now in standard form. Go ahead and write down the second problem, pause the video, and work this problem out. Okay. The first step that I did was multiply everything by 3 to get rid of the 3 in the denominator of negative 8/3 x, which gave me 3y equals negative 8x plus 12. Then I move my x term to the other side in order to rearrange into the correct order, and that gave me 8x plus 3y equals positive 12. Since at that point my a term was positive, I was finished with the problem. All right, moving on down. This first problem we have here is y plus 1 equals 3/4 times the quantity of x plus 4. This one is written in point-slope form. All right, now you have options with this. I think personally the best thing to do is to first distribute, because if you want to get rid of that fraction, don't forget it does not get multiplied to the quantity on the inside. So I think it is easiest to go ahead and multiply my 3/4 out. So I have y plus 1 equals 3/4 x, and 3/4 times 4 gives me positive 3. Now at this point, I can go ahead and get rid of that fraction by multiplying everything now by 4. If you would have done it in the step above, you would multiply this term by 4 and these two terms, but you would not multiply the quantity since that would multiply it out twice. But now that I have no quantities and I'm getting rid of this fraction, I can multiply it out to all of these terms. All right, so I'm going to multiply 4 to y, which will give me 4y, 4 to positive 1, so positive 4, 4 to 3/4 x, which will leave 3x, and 4 to positive 3, which will give me positive 12. All right, my next step, I'm going to get this constant term to the other side of the equation to my other constant term. So I'm going to subtract 4 from both sides. And now I have 4y equals 3x plus 8. And now notice at this point, it's very close to slope-intercept form. If I had to get this problem slope-intercept form, I would divide everything by 4 and get y equals 3/4 x plus 2. But I'm going to standard form, which means I need to bring my x term to the other side. So I'm going to subtract 3x. And so now I have negative 3x plus 4y equals positive 8. Now the last time we had done this with our a term not being a positive number, we multiplied everything by negative 1. You can also have the option of dividing everything by negative 1 because it is the same exact process. So negative 3x divided by negative 1 is positive 3x. 4y divided by negative 1 is negative 4y. And 8 divided by negative 1 is negative 8. Now I have everything in the correct spots. There are no fractions and a is positive. All right, go ahead and write down the next problem, which is negative 4x minus 20 equals negative 5y. This here is just a rearranging format. Go ahead and pause the video and get this into standard form. Okay, for this problem, please note that there is different ways you could have rearranged it. The first thing I did is I added my constant term of 20 to the right side of the equation. Then I added 5y to the left side of the equation, which gave me negative 4x plus 5y equals positive 20. Then I multiplied everything by negative 1 to make sure a was positive to get 4x minus 5y equals negative 20. All right, so let's move on to the next problems. Instead of rearranging now, we actually have information to put into these forms. So the first problem we have, the slope, which is m, is 8/5, and the point that is given is 0, negative 3. So I'm going to make little notes to myself here that I'm given the slope, and this point right here we need to identify as the y-intercept. Not just any points, but since x is equal to 0, we were given the y-intercept. So since I'm given the slope and the y-intercept, I can start by putting this in the form slope-intercept form as y equals 8/5 x minus 3. Now we're at the same point we just did above where we have to rearrange. First thing I'm going to do is get rid of my fraction by multiplying everything by 5. So I have 5y equals 8x minus 15. Bring my x term to the other side. and I have negative 8x plus 5y equals negative 15. Now, since my a term is not positive, I can either multiply or divide by negative 1. It does not matter which one you do. It's the same process. Just show your work. So now I have positive 8x minus 5y equals positive 15. All right, that's in standard form. The next problem we notice here that we are given a slope and a point. This time it is not the y-intercept because x does not equal 0. So since I'm given a slope and a point, I can put this in point-slope form. So I'm going to start with y minus my y value of my point, which is 5, equals my slope, negative 3, times the quantity of x minus the x value of my point, which is negative 3. So I have y minus 5 equals negative 3 times x plus 3 from that minus and negative. All right, once again, you've got options. The first thing I'm going to do first is distribute this negative 3 to both of those terms. So I have y minus 5 equals negative 3x minus 9. Then I'm going to add 5 to both sides, so my constant is together. And I have y equals negative 3x minus 4. Notice right here, I'm actually in slope-intercept form, but I've got to bring that x term to the other side in order to be in standard form. So I have 3x plus y equals negative 4. Everything is in the right spots, there are no fractions, and a is positive. So I'm in standard form. So this one we started in point slope, we solved to actually get into slope-intercept form, and then we rearranged to get in standard form. So this one you actually got to see all three forms of this problem. All right, let's get some more practice in. The next one, your slope is 2/3, and a point given is 3, 3. Pause the video and try this problem out. All right, first thing I did was put into point slope form. Then I distributed my fraction. Then I multiplied everything by 3 in order to get rid of my fraction. And then I added 9 to both sides to get my constants together. Then I brought 2x to the opposite side, which left my a term to be negative. So then I multiplied everything by negative 1. So I have a positive 2x minus 3y equals negative 3. Awesome. Next problem. I'm given the 2 points, negative 5, negative 1, and 4, 5. Now in this case, it's very similar to the last problem, except I need to calculate my slope first. So I'm going to calculate my slope by using my change in y values, 5 minus negative 1, divided by the change in my x values, 4 minus negative 5. Both of those negatives will change to a positive, and I have 5 plus 1, which is equal to 6, and 4 plus 5, which is equal to 9. So this problem will simplify with the slope of 2/3. Now that I have my slope, I can choose either one of those points and I can put it into point slope form. Pause the video and finish this problem up. Okay, I used the point negative 5, negative 1. So I did y plus 1 because minus a negative equals 2/3 times the quantity of x plus 5 from minus a negative 5. Then I distributed my 2/3 and multiplied everything by 3, which is my GCF. So I ended up with 3y plus 3 equals 2x plus 10, since those 3's canceled off the 3's on the bottom. Then I subtracted my 3 to collect my constants on the right side. Then I subtracted my 2x to the left side in order to get into standard form, which left my a term to be negative, so I multiplied everything by negative 1 in order to get my final answer in standard form as 2x minus 3y equals negative 7. All right, what I want you all to do is move down to the next problem. This one is 2/3, 2,3, and 2,1. All right, just like the last problem, I'm going to calculate my slope first. So I have 1 minus 3 for my y values, and my x values, 2 minus 2. 1 minus 3 is -2. 2 minus 2 is 0. This slope is undefined. Now, we don't have a form to put this in because we would either be given a slope and a point or a slope and a y-intercept. In this case, where our slope is undefined, we still need to get this in some type of equation form. Well, if you remember our Hoy-Vux, VUX, which represents our undefined slope, this was that vertical line on the graph, which was always our x equals equation. Well, in this case, my x values for both of these points, from 2, 3 and 2, 1, the value of x is 2. So if I get an undefined slope and I go look at my x values, that tells me what my equation is. So the equation is x equals 2. Now, this is actually in standard form. The x value is on the left side. There is no y value. And my constant is on the right side, so everything is in the correct order. There are no fractions. And last thing to check, my a is positive, which is +1 in this case. So this is in standard form. All right, moving on to the next problem. Go ahead and jot down this table. We have our x and y. The first point is 5, 5, then 10, 7, then 21, 11.4, and 25, 13. If we are given a table, we can calculate the slope by finding the change in y over the change in x. And in this case, my change in y has an increase of 2, and then we have an increase of 4.4. Then we have an increase of 1.6. Now I'm going to check my change in x values. From 5 to 10, we have 5. From 10 to 21, we have 11. And from 21 to 25, we have 4. Now, the reason I find the change in y over the change in x for all values is because we are trying to figure out, first of all, is this linear and can it be written in a linear form? Well, now I'm going to check my division. 2 over 5 gives me a slope of 2/5. Then I can check the other ones. 4.4 over 11. Well, if you type that into your calculator, 4.4 over 11, we get 0.4, which changing back to fraction form is 2/5. And then 1.6 divided by 4 is also 0.4, which changes to 2/5. So 2/5 is my slope for this problem. Next thing I'm going to do is put it into point slope form, since on this table we have lots of different points. It doesn't matter what point you use. You can use any of them. Just get the final form into standard form. Pause the video and finish this problem up. Okay, after using the 0.55, I distributed my slope, multiplied everything by 5 to get rid of the fraction, combined or collected my constants to the right side, brought my x term to the left side, and multiplied everything by -1 to get a final answer of 2x minus 5y equals -15. Okay, flip your page over and let's begin on the word problems. Number 1. Pedro walks at a rate of 4 miles per hour and runs at a rate of 8 miles per hour. Each week, his exercise program requires him to cover a total distance of 20 miles, with some combination of walking and or running, which means he does not have to do both, but he could do one or the other. Write an equation in standard form that represents the different amounts of time that Pedro can walk, x, and run y each week. Okay, so important information here. We're going to write this in standard form. We know that the walking is represented by x and that the running is represented by y. So when I go back to the problem, I know that he walks at a rate of 4 miles per hour and that he runs at a rate of 8 miles per hour. And then each week, he needs a total distance of 20 miles. So in order to write my equation, I'm going to match up. If it's 4 miles per hour, and I have x representing by the amount of time, which is x in hours, I can have my first part of this equation as 4 times x, because that represents 4 miles for every hour. And same with my running. I have my 8 miles per hour for my running, so that is 8 times y, for 8 miles for every hour. Then I know this, it says here the total distance is 20 miles. Well, total means to add. So if I add these two equations together, it should equal a total of 20, which now we have standard form. 4x plus 8y equals 20. The next part says graph your equation, and now this is in standard form. In the right form, a is positive. Graph the equation to label your axes. Well, I know my walking is x, so this is hours walking, and my y are the hours running. Well, if you remember back to standard form, we graphed this using the x and y intercepts, and I'm going to use this by using the cover-up method. If I'm finding the x-intercepts, that means y equals 0. So I'm going to cover up my 8y and divide. And when I divide 20 divided by 4, I get positive 5. So positive 5 is my x-intercept. Using the same method, if I cover up my x value and divide by my y, 20 divided by 8, I get 2.5. My graph is only in the positive since hours cannot be negative, so all I have to do is connect my x and y intercept, and this is my graph. Now, doing my domain and range next. Reasonable domain and range, I can actually run for part of an hour or part of a mile. So both my domain and range will be continuous. I'm just going to put these in algebraic notation. I notice my walking, my x values are from 0 to 5. So from 0 to 5. And my y values are from 0 to 2.5. And you can put those in set builder notation as well, but I just quick-handed this one in algebraic notation. The last part says, what is the y-intercept? And describe what it means in the context of the problem. My y-intercept I already found was 0, 2.5. And in the context of the problem, this is when we described our standard form. So 0 represented by walking, so Pedro can walk 0 hours or no walking and run 2.5 hours to cover the 20 miles he needed in combinations. Awesome. Let's move to the next one. A 100-point test question has X questions worth 2 points and Y questions worth 4 points apiece. Write an equation in standard form that describes all possible number of questions that may be on this test. Pause the video and try out part A. Okay, since X was represented by 2 points apiece, I have 2 times X, and Y represented by 4 points apiece, so 4 times Y. My total this time was my 100-point test. So I have 2x plus 4y equals 100. All right, part B says, if you have 24 questions worth 4 points apiece, how many questions will be worth 2 points apiece? Well, I read in the beginning of my problem that y was my 4 points apiece. So I'm going to plug in 24 in for y, and then I'm going to solve. So 2 times x, oops, not 24 yet, times 4 plus 4 times y, which is 24, and solve. So I have 2x, oh my goodness, hang on. Looks like I'm writing in fast mode, but I just can't get this scroll down to where I was at. Okay, so I have 2x, 4 times 24 gives me 96. Solving for x, I'm going to subtract 96. And divide by 2. So I have 2 questions that are worth 2 points apiece. What is the x-intercept and what does it mean in the context of the problem? Well, you didn't have to graph this one, but use your cover-up method to find the x-intercept and explain what it means in the context of the problem. Go ahead and pause the video. Okay, in order to find my x-intercept, I plugged in 0 for y, which is like our cover-up method, and I solved by dividing 100 by 2, and I got 50. So 50, 0 is the x-intercept. Don't forget to write that as an ordered pair. And this means if there are 50 2-point questions and no 4-point questions, the test will be 100 points total. All right. Okay, number 3. Lance has 28 feet of fencing. He wants to use the fencing to enclose as much of his rectangular garden as possible. Write an equation to represent the relationship between the possible lengths x and widths y of the garden's fencing if Lance wants to use all 28 feet of fencing each time. All right, this one doesn't give us a whole lot of information except the fact that he has 28 feet of fencing and he's making a rectangular garden. Now, fencing would be around something. And if I'm talking about all the sides around a rectangle, that is my perimeter. So I do have the equation perimeter equals either adding up all the sides, WW plus L from the length and the width, or we also have it as 2 length plus 2 width. Now, it told us in the problem that x is the lengths and y is the widths. So when I'm going to write this, I'm going to use my perimeter formula, 2x, because x is my length, plus 2y, because y is my width, equals, and the perimeter that I have is the 28 fencing. Okay, and part B says, if the garden is 5.5 in length, how wide is it? Well, oops, let me erase that. 5.5 in length means I'm going to plug in 5.5 in for x because x is represented by length. Pause the video and solve this problem. Okay, plugging in 5.5 for the length, I solved for y, which was my width, and I got 8.5. So 8.5 feet wide. And we can have a decimal for this answer because if you're talking about measurements, measurements can be written as decimals. All right, so let's move on to the last problem. Susie has dimes and nickels in her pocket. She has a total of $2.50. Write an equation that represents the different amounts of dimes, x, and nickels, y, in Susie's pockets. Well, we know in her pocket she only has dimes and nickels, and her total is $2.50. Now, this one doesn't actually explicitly say what our rates are in this problem when we're looking for the rates. But what we do here, since our total is given amounts in the amounts of money, we have the totals or our rates for these in money. So my dime, a dime is worth 10 cents. So if I have it written in dollar formation, my dime would be 0.10 or 0.10 for a precise decimal. And nickels, since they're worth 5 cents, it'd be 0.05 for my nickel. So starting with my x variable, I have 0.10x plus 0.05 y equals my total, 250. Okay, so there's your equation. Go ahead and pause the video and solve part B. Okay, if Susie has 10 nickels in her pocket, I plugged in 10 in for y since y represent nickels. I multiplied, subtracted it over, and divided to get x by itself, and I got 20. So her total of dimes in her pocket is 20 dimes if she has 10 nickels. All right, that's the video lesson for today.